analytics was. And we kind of understood that 80% of our tasks run on descriptive analytics, because that's where the flavor of statistics actually starts with. And without some kind of intro to statistics, it will be kind of little difficult to understand how we actually interpret most of the data that we kind of see when we use a kind of algorithm on the data. So descriptive analytics forms a very basic foundation for any kind of machine learning algorithm to be applied for the data that we have to build a model. So and after understanding descriptive analytics, that's when we apply a predictive model. We've also seen the kind of disruptions that are happening in the marketplace, taken any kind of domain perspective. There is analytics in play. So we've just understood that every process to build a data product does have a data science that is required. So we've taken example from the health industry, from the automobile industry, and the education perspective as well, and seen how our lives are actually intimately driven by data products, and how an improvisation happens using different kind of algorithms that we have. And we've also seen the kind of architecture that is there in the analytics or data science, this thing that you have the machine learning phase, which is actually the architecture which actually changes the whole game, wherein it gives you a bird's eye view rather than just a worm's eye view of the data. Because organizations today just see the tip of the iceberg. They just want to know what is driving sales. They don't know. They don't ask questions like, what is driving that sales? If we increase promotions by 5%, how much sales would increase by? So those kind of questions are unknown information that analytics, which is inbuilt within the architecture as of today, will give you that concise information. Using different analytical tools, we can actually get that information out. Obviously, the market for analytics is on the rise, and there is a very good career path for the analytics, because as a data scientist, we will be defining hypotheses. You would kind of know what your data looks like and what are the different machine learning algorithms to actually apply for that kind of data. So we will go into a few questions that actually come up, and they're on the rise, but I think this is something that we've seen. So today what I actually want to talk about would be more on the aspects of the data. Now, data comes in different types, and the first, when we get the data set to hand, it is in rows and columns, right? So first aspect that we need to know is, what is the data that we have to hand? What are the variables? Because depending on the data we have, we are actually going to apply a statistical algorithm to it, right? So we need to know what the data is like. So data is of two types. The first is qualitative and the second is quantitative, right? So when you have qualitative data, it is in character form. Anything which relates to an alphabet is qualitative. Quantitative is in numeric format, okay? So again, in qualitative, we've got three kind of data that you can actually classify your data into. The first being binary. Binary is nothing but your dichotomous, which is, it just got two outputs, right? Either true or false, pass or fail, excellent or bad, or you can have male or female. So it's just got two outputs. The second is ordinary, and the third is nominal. So nominal data is any data which is in character format but doesn't have a binary output. It's got a lot more options. Like, I want to know in race, what are the different kind of options? In the city of Hyderabad, what are the kind of localities that I have? What are the name of schools that I have in this particular locality? So it is data that is not binary and can have any number of options to it. That is nominal data. What is ordinal data? Ordinal data is nothing but nominal data, but it's got an order to it. So if I say I want to know the number of schools in my locality, also want to give an order to it, like rate the schools, or tell me the schools which with the highest priority given to the least amount of travel within my locality. So when I give an order to the nominal data, it becomes an ordinal data. Questionnaires have this kind of ordinal data attached to them all the time. The second kind of data is of qualitative nature. And the first is discrete variables and continuous variables. So discrete variables are information that can be categorized into classifications, and they're based on counting. So it is the number of times if I toss my coin, what is the number of probability of times that I could get a head or a tail. That is discrete data. Continuous data is data that arises from, that can be measured on a scale, like weight, kilograms, salaries, temperatures. So that is continuous data. It can take infinite numbers. I mean, because it has that numeric of a decimal placing attached to it. So it can take any number of outputs. So now, depending on the data that we have to hand, we perform descriptive analysis to the data. Now, if I say nominal data, there is a kind of limitation on the kind of amount of descriptive analysis I can do to nominal data. I could probably calculate mean and mean statistic, which is nothing but your average, for nominal data. But for something like continuous data, I can perform any arithmetic operations like addition, subtraction, multiplication, division, and also calculate the mean, median, mode. All of the information of this descriptive statistics that I can perform can be performed on continuous data. So now, once I understand what are the calculations I can do and what explains most of my data, it is your continuous data which actually gives you all of it, all of the output. So the kind of statistics analysis that I would use on all of this data is very limited. Now, let's take an example. Let's say if my data is numeric in format, I will go and apply linear regression. But if my data was categorical data is nothing but your qualitative data, I would apply something, and I want to understand the relationship between data, I would apply something called a crosstab analysis. But if again I want to understand the relationship between numeric data, I will apply a technique called correlation analysis. So depending on the data that I have to hand, I apply a statistical tool to it. If data was qualitative and I want to understand the relation, I apply crosstab. If data is numeric and I want to understand the relation, I apply a different statistical analysis, which is correlation analysis. So it begins at the kind of data that we have to hand. And how much of that, again, if my data is, I want to understand, after knowing what my data looks like, I want to understand the dependent and the independent variables. Now, trying to understand what the dependent variable is something that is very, very important, because we have limitations on the number of dependent variables that we can have in the data. But your independent variables can be numerous in number. And by the number of iterations we run on the data, independent variables start actually getting, we kind of delete few independent variables which are not making a significant contribution to the data that we have to hand. So dependent variable understanding is very important. So let's take an example. Let's say time spent studying causes a change in test score. But the test score cannot cause a change in the time spent studying. Now, what is the dependent variable here? Is the test score. Okay? And the independent variable is time spent studying. So independent variable is time spent studying. I could also have things like the number of books I'm referring, the kind of institute I go to learn the course. So I could have numerous independent variables that actually impact on my dependent variable, which is my test score. And some of the independent variables could have a significant impact, some of them could have a very less significant impact, which actually may not cause a very impact on the test score. So I will start to erase those variables which are not explaining most of my dependent variables. So dependent variable is what you're trying to predict, and the independent variable is information used to make the prediction. So your independent variable actually influences change in the dependent variables. Now, when we go into advanced tools like linear regression, logistic regression, we get something like a R squared, which actually explains how much of the dependent variable is actually being explained by the independent variables. So we will see that as we go ahead in a few of the statistical tests. Most of the model building actually works on trying to understand what your dependent and independent variable is. And dependent variables, exploring and trying to fix one to be an independent variable is a very challenging task, and we almost do that in Cognizance with the client that we interact with most of the time. So we do a lot of brainstorming sessions to actually get that one thing right. So it's very critical for understanding the data. So once we know what the dependent and the independent variables we kind of fix a statistical test to them. Now, if my dependent variable is dichotomous or binary, and my independent variable is numeric, I would use logistic regression. But if my dependent variable is also continuous data, I will use linear regression. So depending on the variables, I will use a statistic test to build my model. And also depending on the kind of independent variables and the dependent variables, my kind of machine learning algorithm that I apply will actually play a key role in analyzing the data to hand. So for every kind of analysis that we bring in when we build the model, we kind of get a significance level, the hypothesis. We need to actually say, we need to define the null hypothesis and the alternate hypothesis, because almost nearly we want to reject the null in favor of the alternate hypothesis. So that's the first step in statistical analysis of the data before we go ahead, because we make predictions based on an understanding of economic theory. And then we want to reject and say that there is not much of a difference between the kind of analysis that we're doing, and there is a very limited sampling error in the data that we have to hand. So what is the actual versus the prediction that I have, and what is the sampling error that I've got to hand? So these kind of understandings are what we kind of nearly do when we analyze most of the data, building the model. So we also get, we want to understand the relation between two means. We kind of use tests like a t-score or a z-score. I use a t-score when my sample size is less than 30%, and I use a z-score when my sample size is more than 30% of the population. Because when I work on data, I am not actually taking the whole of the data, but I'm actually picking a sample from that data and exploring that sample. But my sample should actually nearly look like my population, right? So when I work on the sample, I'm actually training my model, and I'm going to test my model on the remaining data, and I'm actually going to say if my model looks perfectly well or not using different diagnostics that I have to hand. So when I kind of get into understanding what my data looks like, I will start to explore my data using, I will have to look for outliers in my data. I've got to look for any kind of missing values in my data. How am I going to impute missing values? And then look for outliers which don't fall within the normal range of data, and which can actually influence my data to look otherwise. These are kind of things that I will start bringing into normal format before I actually go any further, before I even do descriptive analysis of my data. So we need to check every parameter that we have in a very concise way, because at the end of the day, what we say is algorithms are just like an accuracy. They don't give you they predict it quite well. It is an approximation. It's not something like accurate data. So let's take an example of a caricature. A human being just looks the way we are, but when we draw a sketch of ourselves, it is an approximation. So just like mathematical models and statistical models are just a caricature. So they give you a kind of information that is accurate in its way. So those are the kind of things that we need to look when we kind of work with data. Any questions as of now? Okay, I'm going to actually, I've got a few questions out here and I'm going to just try to answer them. The first question is, I've worked on SAP BW, BOBJ. How do I transition to become a data scientist? So I would say that the few steps are execute your first data science pilot. Step 1 being learn R. Zero in on business problem to be solved. Set up R and get access to data and kind of explore it. Learn basic statistical techniques of reading your data types. What are the kind of techniques that you can apply on the data? How do you actually interpret your data from the kind of numeric values that you get as outputs in your data? And trying to understand what your dependent variable is, and trying to understand how you set your null hypothesis, alternate hypothesis for the kind of questions that we have to hand, and apply an analytical construct to the kind of data and discover patterns in the data which actually can impact the outcome of your data, and present the final results to the business team. So the next thing is, the next question I have to hand is, should I know probability and advanced statistics? Not really. We're focused on application rather than theory underpinning it. So we will teach you the business problem to solve, how to execute the commands in the platform. So we will go hand in hand with kind of, today we've done variables. The next session will be on understanding what you're sampling, how do we choose a sample from the population, descriptive statistics, and null hypothesis, how do we actually calculate it, and generating random numbers, and from a normal distribution and from a uniform distribution. Before which after which we go into correlation, which is again trying to understand the relation between your data, trying to see what your correlation coefficient, how do you read that, and what is the significance of understanding all that, which completes the statistical tools. After which we will learn basic R, basic coding in R. Then we go into exploratory data analysis, wherein we study principal component analysis, factor analysis, and understanding concepts of multicollinearity, homoscedasticity and heteroscedasticity. So what are these kind of challenges that we have in data, and how do we actually diagnose these kind of things and provide a solution? Then we go into detail of machine learning algorithms, wherein we study each algorithm by itself, and we kind of perform tasks in R by inputting commands, taking inbuilt data sets in R, and kind of trying to study the data, interpreting the data. So obviously, there is not a need to know probability or advanced stats. You will be taught all of it. I'm confused between Hadoop and data science. What's the difference between Hadoop and data science? I would say Hadoop is an environment from which you input a lot of Excel sheet that can actually be of a great vaster volume into R, and explore on the data that you have. And data science is nothing but you're sensing patterns from data to impact business outcome. So you're kind of more on you're going to analyze the data from a perspective that you can give a numerical output to that data that you have to hand. That's the difference between Hadoop and data science. The next question I have is, this is a big shift for me. In your experience, how long does it take to make the transition from IT to data science? We've seen people make the transition from 4 weeks to about 6 months. It depends on the kind of time that you want to dedicate to learning the course, the passion that you have really, and the commitment that you show to learning. So somebody who is very new to the whole setup will actually take anything between a month, 2 months if he's very dedicated, because in the meantime, you'll obviously be attending a lot of interviews that we will try to tell you to apply and face an interview. But somebody who is very slow can actually take anything between 3 to 4 months to actually do the same kind of learning. But there will be a lot of help and guidance because it's all in a very structured format. How are we going to prepare you for the data science job market? We're going to do a lot of mock preparatory sessions. There'll be a lot of worksheets we give out, and there'll be a lot of checklists to do. There'll be a lot of reading that you need to actually be doing from the concept and the topic as it is. You'll have, towards the end of the whole thing, you will have a live project to do. And then as and when we touch upon concepts like clustering, linear regression, logistic regression, decision trees, multi-collinearity, you will have a data set wherein you will input the commands and actually see how these kind of outputs come in and what are the challenges and how do you need to diagnose these kind of outputs. So that's the kind of thing that we will be actually putting you through, and we'll give you a lot of information of job alerts that actually come and help you apply for those jobs. After I take the basic intro to data science course, how can I specialize further and deepen my skills? It's actually, the next thing I would see is somebody who actually has a lot of exposure to actually the battery is running low, just hold on. Let me just turn it on. Okay. So for a question of that kind, where a student's actually, a participant has actually done a course in data science and wants to specialize further ahead, there is advanced data science wherein, you can learn time series analysis and also get into analysis like structural equational modeling, support vector machines. So there is more of advanced analytics that one can actually align themselves to, and also try to look into data science from a perspective of the domain itself. So any domain as of today has analytics inbuilt in it. So trying to understand it from a domain perspective also helps a lot. So any other questions as of now? There's another one that's come in. I am not an IT professional, but a domain person. How can I get started? So to answer that question, I would say focus on industry use case, and obviously, take the basic intro to data science course, study thoroughly, and you'll be kind of able to actually attend interviews and get yourselves through the first job that you're looking for in analytics. So any other questions as of now? Is it a few questions here? Okay. I've got a couple of questions out here. What all technologies used for data science? Okay. So this is asked by Rishi. The technologies used for data science will be, if you're kind of talking about big data analytics or just from a perspective of what a data scientist does, let me just talk about what a data scientist would use is he would use kind of technologies that go very well with statistical analysis, which can be anything ranging from R, and now Python is catching up with pandas. SAS is very expensive on the licensing front. I think R, from a very open source perspective, looks very appealing to me because the kind of interpretation that you give in with R is very impressive, and also with the kind of visualization that we have, R is very expressive. Nevertheless, Tableau is very good for expressing data, but I wouldn't say R is any further less than what it is. So, and what else? Of course, there are few of these Stata SPSS kind of packages, which are very limited in their confinement to, and they confine themselves to statistical, purely statistical. So there is an ample technologies out in the market, but the widely used ones will be R and Python, as you see. So if you take big data analytics, yes, an understanding of the big data environment of Hadoop obviously does help. That's the question. I think I've answered that, Rishi. The second question is, what language and tool most famous for AI today? Now, I'll be very biased if I kind of really say the tool that's mostly used in the artificial intelligence industry. But I think the kind of scripting that we do in R and Python is very similar. You can kind of obviously relate to it if you've learned one, because the underlying statistical techniques will be the same. The concept remains the same. It's just the way kind of scripting that we do in different softwares that we have available. So I would say R and Python are really doing very well in the market as of today because of the different packages that you have that can be explored for domain-specific industries. The next question is, what are the challenges we face for a Hadoop or other developers, data analysts versus manual testing, ETL testing? The challenge is, if somebody wanted to learn this course and really felt, they were getting challenged by people already in the industry, be it the big data or the analytics environment. I would say that because you have your domain perspective knowledge, obviously you are a subject matter expert in the kind of area that you worked in. So it is an add-on to the skill that you existing have. And because analytics is picking up in the market, trying to learn a new course and get into it with the kind of experience that you already have is an added advantage. So there is not much of a challenge that I see, because all of us, be it a data analyst or a big data analyst, learned the course before actually they did it. They kind of went and implemented it on the real-time work. So there is no challenge that I see. It is just an add-on as a skill to the existing work that you have. The next question I have is how to test application enabled using data science. Are you going to cover testing aspect? Now, how do we test the application is, we kind of, as I said initially, that we, when we make our predictions, and we kind of see what the actuals will be from the analysis that we perform on the data. Now, we also set what your null hypothesis is and your alternate hypothesis, and whether we're going to reject the null in favor of the alternate, or we're going to have the null established and reject the alternate. So one of them is the kind of test that we set ourselves to before we actually go into the actual information that we see in the data. And as and when we go ahead and apply a machine algorithm on the data that we have to hand, we also have kind of diagnostics that we use as parameters to see how much of the data is actually being very significant to the model. So at every stage, we do a lot of testing on the data. And something that we don't need, we kind of try to give it a different look to the data. Now, if my data is very skewed, if it's not looking very normal, I would kind of normalize or scale my data, right? So that's one diagnostic I would do. After I normalize my data and bring it into the normal parameters of my 3 standard deviations from the mean, then I would go ahead and check for the next level, trying to understand the relation between my data. So at every stage, I'm actually testing and diagnosing my data to see that I don't get further challenges in the data. Before actually even I go ahead and build a model or apply a modeling technique to the data, these are different tests and analysis that I do on my data. Any other questions? Just gonna go, yeah. What languages and tool is most famous today? As I said, I'm not going to be very biased. There kind of a lot of tools to be explored in the market. For statistical analysis, there is Strata, there is SPSS. You want to do analysis of your data, there is R. You want to interpret your data in a very stronger way, there's R. You want to do complex scripting, there is Python. So there are different kind of tools for different perspectives to the data that you have to hand. So there are many tools, and the most familiar tool that I could relate to will be R programming, because I do most of my analysis in R. So I would go with R any day. With no experience, to already one who is having it will be challenging to appear for interviews. Not really, because the kind of course that we're going to put you through will be a full, rigorous, thorough understanding of the whole thing. So it'll be very easy to pick on the nomenclature or the kind of interview questions that will be asked, because there's obviously a lot of demand for the skill, and freshers or people who don't have experience to people who have reasonably good amount of experience are the people who are being the target audience for the kind of roles available. So there is no challenge as long as the course is actually learned in the right flavor. what is Tableau and how is it different from R? Now, Tableau is just a visualization application. I mean, I'm very limited in my scope of usage of Tableau, so I may not be the right person to judge from the Tableau perspective. But R is a statistical analysis versus Tableau, which is just a reporting or a visualization. It is very expressive. It is very colorful in the way it is, and Tableau is very dynamic in nature. Unlike R, which does interpret and give out outputs for that kind of analysis that we do to have. So how I would look at it is Tableau is very good on the visualization front, whereas in R, you can analyze your data, you can interpret your data, as well as visualize your data. So what is R developed on? I think R was developed initially on a language called S, and then it went into calling itself as R programming. So any tools available for testing? I would say tools are, again, any kind of statistical techniques. Like I would say I would go and check, I want to check if my data has no outliers. So the kind of tool I would use is a box plot. I want to check if my data is normal. I would use something called a histogram. I would want to check if my data looks normal and there is not much of a variance in the data. So I would plot a graph and I would kind of perform tests to check. I would do an Anova test wherein the assumption of Anova says that if different samples come from different populations with different means, and the underlying assumption of Anova is that it should have the same variance. If it has unequal variances, then I would use a Welch test to work with the degrees of freedom wherein it corrects the unequal variances in the data. So the kind of different ways I would use, so obviously, yes, we do have it at every stage. When I say tools, I mean to say automation testing tools like no. There is no need to actually use any automated tools for analyzing your data. Obviously, Facebook and all does it in a different way, but in the standard format of data, which comes in, there is nothing of that kind that we have because we are analyzing and diagnosing data at every stage. So, any other questions for me? Okay, thanks, Rishi. Anything else as of now? Any other questions? Okay. So we'll call the session off for today, and we will connect further as soon as we can. So are we good to call it off for today? Okay. Thanks everyone for coming online and trying to understand what the kind of data variables could be to as a next step to. Okay, I've got another question. What are the replacement jobs that data science can have? Replacement jobs that data science can have. When you say replacement, Joe, what do you mean? What replacement jobs that data science can have? From the kind of understanding, correct me if I didn't get your question right. When you say replacement jobs that data science can have, are you trying to say what is the career options apart from a data science skill? I would say, okay. No, okay. So are we trying to say what are the skills that data science is replacing at the moment? Mm, okay, data science will be replaced with what kind of jobs? Okay, now data analytics is kind of getting replaced by business analytics. So companies kind of feel that they need more of an understanding of the data from a perspective of why are things happening, what is driving sales, what is if promotions were increased, what could impact the revenue of the firm. So they're kind of going into how questioning factors, how, when, what, which, why kind of a thing. So business analysis will not interpret your data in a very concise fashion, giving out numerical outputs. So which is what data science is actually good, because we interpret most of the data. So it is replacing most of the business analyst roles, as you see as of today. Most of them are getting converted into data analyst roles. So we couldn't have first webinar because of technical issues. So when do we have third seminar? Okay, we'll kind of organize that at the very earliest and get back to you, Akhil, on that question. Okay, so we will address that as soon as we can within the next couple of days. Nowadays, agile in place, where data science role is fit into it. Nabanit, nowadays, agile in place. Okay, I know that agile is a kind of a business analyst software package that business analysis done mostly on agile, where data science role is fit into it. How does a data science role fit into the business analyst role? Is that the kind of question that you're trying to ask me? If I'm not wrong, Nabanita? Yes, okay. Now, I think a business analyst and a data analyst or a machine learning algorithm developer or a data scientist are two different roles. There is no fitment between a business analyst and a data analyst. Um, analyst gives you a bird's eye view of the data that you have to hand, wherein I would say I wouldn't discourage or limit a business analyst to give you a worm's eye view of the data. But nevertheless, I would kind of say that with the kind of statistical techniques that we have available, what a data scientist uses is more very detailed. So we kind of it is like a blood test to a blood test of the data to the organization that we have. We kind of giving in more details, more reports, more analysis, more outputs on the data that we have using different techniques. So I would kind of say both are different job profiles, business analyst and a data analyst. And data science is catching up. So the next 5 years will be the more of skill in demand for a data scientist. Yeah. Presently, I'm working in QA and what are the prerequisites to learn this and what are the challenges I will face to learn. So as we were kind of discussing few questions that I addressed previously, I would say because you are working in quality analyst already, and how are you going to actually transition to learn and become a data scientist? So I'm become successful in executing your first data science pilot project. So we would encourage you to learn the course, get accustomed to understanding what basic statistic concepts are, and how they fall in alignment with machine learning algorithms, and then bringing forward both of them into programming that in R and trying to interpret most of your data and understand your numerical outputs that you bring out in R. So this is kind of a holistic path to becoming a full-fledged data analyst, which leads you to become a data scientist. So got to learn R, familiarize with statistical concepts, right, and interpret most of your data. So that's the kind of thing that we do teach. We give you a lot of worksheets and kind of assignments to do. We kind of give you the coding that you need to be writing after every algorithm that you read. So the challenge is, I would say, because you will be learning from the concept, we will be helping you and teaching you and clearing most of your doubts with it. So there will not be much of a challenge that I would look if, apart from the fact that, you know, you could be, it could be difficult to grasp initially, but otherwise, I don't see much of a challenge. And prerequisites, there is nothing much that you should know, because we would expect the participant not to know anything. And obviously, for the benefit of everyone, we would start from basics to actually going in detailed fashion to cover up everything that we can do. So any other questions that I have? Sure, Sridhar, thank you. Any more questions? Okay, I think the kind of only pending question was from Akhil about the first webinar, and when is the third webinar going to be actually organized. We shall communicate that at the very earliest to you, and organize that, I think, at the earliest, okay? So apart from that, I think we've covered almost everything and answered every other question. So we will get back to all of you on this third seminar aspect, okay? So, okay, I got another question. Is there are more data scientists in the industry who is going to do other jobs? Okay, now, because Joe, the kind of question I'm trying to answer was from a perspective, why is data science popular nowadays? Data science is obviously picking up because of the limitations that data had, previously, that we were actually performing. So we kind of explored that and understood that we need to study the patterns and signals in the data using kind of statistical techniques, which kind of gives us more detailed information of the data. So that's when the skill actually started to pick up, and we are intimately surrounded by data products around us, which are created by a data science process, which again requires a data scientist to actually create that product using different algorithms. So the skill is actually growing in the kind of requirement that is there in the industry. So it kind of gives you a lot of new information that we didn't know that the data had previously. So if you kind of take in business intelligence, you were kind of just trying to answer a few questions. So the reporting tools like Cognos or business intelligence, they give you a very restricted answer to your questions. But whereas when you go into data analysis and understand your data, you can get in more perspective of your data from the initial screening of your data. When I screen my data initially, there is so much that I get to know in the data. So you can understand and study your data from different perspectives. So that's the reason why the skill is actually more opted for in the industry as of today, and there is more demand for it. Any other questions? Okay, thank you, Joe, and thanks everyone for attending. So I'll take it that there's no more questions as of now, and we'll end the session.